Hello and welcome everyone. We're just going to wait a couple seconds for people to trickle in. I see we've got a lot of participants joining already, so that's wonderful. And I'll just pull up the slides in a moment. Can you all see my screen? I just clicked the wrong thing, but slideshow. Well, welcome everybody to the spring version of the Adaptation in Action webinar. I'm Jamie Mosel, and I've got some teammates here as well who will be joining us. But this is our spring webinar, and we'll be talking about changing rainfall patterns and flood risk. And it's actually become kind of relevant because it's been raining quite a bit, so you never quite know. But I have my special rainfall earrings on to highlight that. We're hosted by the University of Minnesota Climate Adaptation Partnership, and we're very lucky today to have Ketzel Levens from the National Weather Service based in Duluth joining us today, and also Chanel Mueller from the U.S. Army Corps of Engineers. And I'll get into a little bit more of introductions as we go. But thank you all so much for being here, and let's get started. So just to give you some highlights of upcoming events, we'll also have a summer adaptation in action webinar. That'll be August 20th, same time, noon to 1:30. And then we also have some upcoming webinars that are kind of a special feature. It'll be talking about the Minnesota Climate. So that is the Minnesota Climate Mapping and Analysis tool. That's a new tool that's come out from MCAP that's been years in the making, and we're really excited to share it now with the public. It'll give you basically an overview of how to use the basics of climate data and projections and navigating that tool. And Susie just shared the link in the chat, so please feel welcome to check that out. It's open to everyone. We have one coming up on Thursday, May 23rd, so this week from 3 to 4 p.m. So please join us if you're able to, or to join us for one of the future sessions. And then also, if you missed any of our past webinars, you can view the recordings here on our YouTube page for the University of Minnesota Climate Adaptation Partnership. I've placed the link right here. Most recently, we had our winter webinar, which was focused on climate threats to outdoor recreation with the American Birkebeiner, co-hosted with the University of Minnesota Tourism Center. And we also had Grand West Marathon talking about how climate is impacting outdoor recreation. So there's lots of resources and past talks from over the years, so you can check out there. So now I'm very, very happy to introduce our speakers. Again, we have two speakers today. First, Chanel Mueller will take it away. Chanel is from the U.S. Army Corps of Engineers, and her position focuses on climate preparedness and resilience, that community of practice. So I think she will be an excellent speaker to talk about some of these issues related to adaptation, changing rainfall, and climate change in general. Our next presenter is Ketzel Levens. She is a meteorologist with the National Weather Service in Duluth. I also happen to know she's an avid skier, so she might be interested in the outdoor recreation presentation from the winter. And she'll present after Chanel. Just some friendly reminders and housekeeping for the webinar. So we'll end at 1:30, and all participants are muted during the presentations, but we will have a discussion with some guided discussion questions and Q&A from the audience at the end of the presentation. And then, as I mentioned, this webinar will all be recorded and posted on MCAP's YouTube channel at a later date. This is just to orient you to Zoom. So again, you're muted, but please use the Q&A feature to ask questions of your presenters or of us. And we'll try and answer if it's something relevant at the moment. We might be able to type in an answer, but usually we'll save them till the end. And then you can type your own question, or you can also upvote a question that you'd like to see answered. And then again, we'll end at 1:30. Oh, and these are our discussion questions for the end. So that's the cue for my part to end, and I'll hand it over to Chanel from here and let her share her screen.
I think right now my ability to share my screen has
Oh no.
been disabled.
Oh no. Let me see. Make sure I can. Listen, panelists. Oh, it's been fixed, so hopefully that will work. There we go.
All right. Great. Can you can see it now?
We can, yes.
Okay. Well, thanks for inviting me to speak today. As she mentioned, my name is Chanel Mueller. My background is in hydraulic engineering. I'm a graduate of the University of Minnesota, so happy to speak today. I work for the Army Corps of Engineers out of our headquarters office, and I help to manage our climate preparedness and resilience community of practice. So it is the policy of the Army Corps of Engineers to integrate climate change preparedness and resilience planning and actions into all of our activities. So as part of this, we have a climate action plan, which is soon to be published. An update is soon to be published as our climate adaptation plan, and that describes the steps our agency is going to take over the next 2 years to bolster adaptation and increase our agency's actions targeted at increasing resilience and preparedness for the impacts of climate change. Our community of practice was first established in 2014, and it consists of Army Corps staff who have who are focused on global and climate change issues. So to provide some context, why is it important that we get prepared for the effects of climate change? And this slide shows why it's imperative that we take action now to both mitigate for climate change impacts while also adapting to the potential effects of a changing climate. This is because even if we could dramatically reduce the rate of carbon emissions in the short term, we've already baked in a lot of change into the Earth's climate pie. So for instance, even if we're able to reduce carbon emissions really quickly, temperature would only stabilize over the next few centuries. So that means we still need to take action to adapt to the potential effects of climate change and be prepared for that change. At the same time, it's critical that we also invest in mitigation and in reducing emissions, because every dollar we spend on mitigation now saves many dollars that it would take towards adaptation in the future. So a series of executive orders have required that federal agencies prepare for the impacts of climate change. And in one of those executive orders put out by the Obama administration circa 2013, they provide a definition of resilience, and that's what we rely on as an agency. And it's the ability to anticipate, prepare for, and adapt to changing conditions and withstand, respond to, and recover rapidly from disruptions. And as a result of that, the Corps developed its Resilience Initiative in 2016 with the purpose of mainstreaming resilience thinking, inventorying resilience activities, and developing an enterprise strategy for how our agency addresses resiliency. To support the nation's resilience efforts, the Corps of Engineers has developed a stepwise framework for action as illustrated on the slide. And that's through 4 principles: prepare, absorb, recover, and adapt, which we reference as the PARA principle. And through this framework, we seek to mainstream resilience thinking for effective application of established and emerging practices and procedures. And this will lead to increased resiliency at both the project, system, and community levels. An important part of this framework is the idea of adaptation, which is an adjustment in natural or human systems in anticipation of or response to a changing environment. So a couple of ways we make our projects more resilient to the impacts of climate change are through things like armoring our levees. So we increase the physical level of physical protection and thus reduce non-performance in the future. We also sometimes raise levees. So, and part of that might be building a stronger or more robust levee foundation up front so that we can augment a levee structure in the future if a climate change-based risk materializes. Other ways we add resiliency to prepare for the effects of climate change are by adding redundancy or relocation. Relocation would be something like moving a structure outside of the floodplain if we know that flood risk will increase in the future. And lastly, a really important strategy we take to improving the resilience of our projects is through monitoring and adaptation. And that kind of pulls in this idea, of establishing thresholds, lead times, and decision points so that we can take action to prevent non-performance as a future in the case that a climate change-driven risk begins to materialize. And adaptive management is really effective because it enables us to manage uncertainty and reduces the risk of overspending in the short term. The way that this sort of idea can be applied is that you would identify an indicator variable that you can monitor for to evaluate whether a climate change driven risk is beginning to become an issue. And something that you can monitor for example, would be change in the 1% annual exceedance probability flood stage. And so in doing this, you would select a trigger stage that would require action so that you could prevent future non-performance. And this trigger stage would allow you to have enough lead time for planning, design, and construction, which can require a considerable amount of time, so that when that risk materializes, your project is ready. So on the inland side, the Army Corps of Engineers has guidance for incorporating climate change impacts. So that guidance requires us to consider trends in observed time series data of temperature, precipitation, and stream flow, and evaluate those time series data sets for evidence of non-stationarity. We also require a review of peer-reviewed literature and a summary of that literature in terms of what kinds of trends are being seen in both observed and projected hydrometeorology as far as temperature, precipitation, and stream flow response goes. We also require our practitioners to evaluate projected futures derived from global climate models based on temperature, precipitation, and stream flow outputs. And we kind of try to pull all that information in using a multiple lines of evidence-based approach to define what the residual risk due to climate change is to our project alternatives and measures. So the end goal is to specify potential climate change risks. So we identify a given trigger that could cause a hazard to a feature or measure that we're considering as part of our project and defining the harm that climate change could impose and the likelihood of that risk materializing. And if there is a high risk, we suggest a management action or element to improve the resiliency of the design. As I mentioned earlier, you could build a wider levee footprint up front to allow for future raises if an increase in precipitation materializes in the future, causing an increase in future flood risk that might cause harm to your levee structure. One of the tools that we often offer to our practitioners, which is publicly available at the website you can see on the slide, is our time series toolbox. And this is a tool that enables our users to perform an assessment of hydrologic stationarity using observational time series data. So you can either evaluate preloaded USGS annual peak or peak streamflow or stage data, or you can upload your own data set. So you could analyze whether a precipitation data set is reflective of stationary climate conditions. And the tool allows you to conduct analysis in an easy, effective way. So you can apply a series of 10 different change point tests to evaluate if there's a statistical shift in your data. It allows you to do breakpoint analysis and monotonic trend analysis. It also gives you insight into your data's characteristics and allows you to visualize your data set as well. Another tool that the Corps has developed to support inland hydrologic analysis is the Climate Hydrology Assessment Tool, which is also publicly available and accessible via the website on the slide. It displays simulated streamflow, temperature, and precipitation outputs for both a historic period and a future simulation period of 2006 to 2099. Right now, the data included in the tool are generated from a wide range of global climate models coming from combinations of output from the CMIP-5 project, and it allows you to visualize both representative concentration pathways of greenhouse gas emissions, 4.5 and 8.5. The tool allows you to evaluate the spread in output from global climate models across the variables of interest. So that gives you an indication of the uncertainty associated with projected climate influenced hydrometeorology. The tool also allows you to fit trend lines to the data and allows for visualization of change at both a monthly and annual scale via a series of box plot visualizations. Some of the variables of interest in the tool include maximum and cumulative precipitation, maximum, mean, and cumulative flow, as well as mean, minimum, and maximum temperature. So one recently completed climate assessment that was done within our region of interest, the Upper Mississippi River, from its headwaters to Cairo, Illinois, is illustrated on the slide. So that project development team performed a literature review. Some of the key pieces of literature that they relied on were the Fifth National Climate Assessment, the NOAA State Climate Summaries, as well as a literature synthesis that the Corps developed in 2015 for each Huck 2 watershed in the United States. And based on that literature review, they found that the Upper Mississippi Basin would have a wetter and warmer future. They also performed statistical analysis on a series of observed time series data, including total annual precipitation records throughout the study area, maximum annual summer, fall temperature data sets, as well as seasonal temperature data sets and peak streamflow data sets. And what they generally found was that total annual precipitation in the watershed is increasing, minimum annual and seasonal temperatures are increasing, and that observed streamflow appears to be increasing as well. They also found evidence of non-stationarity in the annual peak streamflow record, with most of the non-stationarities being detected in the observed streamflows centering around 1935 to 45, 1964 to 1980, and circa 1990. The team applied the Army Corps' Climate Hydrology Assessment Tool to evaluate future global climate model-based projections of streamflow. And overall, they found that upstream of the Wisconsin River, there were mixed trends in future streamflow, but downstream of the Wisconsin River, most of the sites evaluated showed an increase in streamflow. And you can see some of the outputs from the Climate Hydrology Assessment Tool on the right of the slide. So here on the bottom, you can see that it allows you to look at box plot visualizations of change in annual mean stream flow. And I should have mentioned that the climate hydrology assessment tool allows you to visualize these climate model-based outputs that have been downscaled at a stream segment scale. So you can select any stream segment in the continental United States and visualize these sorts of results. It also allows you to visualize these sorts of results for temperature and precipitation, but at an 8-digit HUC watershed scale. So you can select an 8-digit watershed in 8-digit HUC watershed in the United States and generate these similar kinds of graphics for precipitation and temperature changes. And it also offers monthly box plots as well. As a final part of this analysis, the team used the Corps' vulnerability assessment tool. This tool is only available behind the Corps' firewall, so it's not publicly available, but it does facilitate the screening level vulnerability assessment at a HUC 4 watershed scale for specific Army Corps of Engineers business lines like ecosystem restoration and flood risk management. And what it does is it generates a cumulative score across a series of variables tied to these business lines. And based on that cumulative score, it evaluates whether the watershed being analyzed is more or less vulnerable to climate change impacts relative to the other watersheds in the United States. And so based on this sort of assessment, using all the 4-digit HUC watersheds in the upper Mississippi River Basin, the team determined that it wasn't as vulnerable to climate change impacts for flood risk management as some of the other watersheds in the United States. Another reference that we have is our guidance for incorporating study-specific projections of climate change meteorology, so like projected precipitation and temperature, as well as projected stream flow response. And this is really a consolidated reference that guides procedures for conducting climate change analysis. And it's meant to increase accessibility to these sorts of data types and to support the appropriate use of relevant projected climate change information in order to inform the Army Corps of Engineers civil works planning process. So where it's applicable is if you're interested in project-specific or watershed-specific applications of projected temperature, precipitation, and stream flow, or if you're interested in trying to alter your design or decision-making specifically based on projected hydroclimatic change. And so the Corps supports the following approach to using climate-influenced projections of hydrology. We want to ensure that a focus is maintained on representing the true uncertainty associated with the outputs derived from global climate change modeling. There's a lot of uncertainty associated with each step in the climate change modeling chain. So it's important that that is communicated and utilized appropriately as relevant to a given project. And what we want to avoid is implying a false sense of precision. And so to support this, we want people to use a consistent set of tools, models, and data sets in terms of approach. And we want to ensure that people are utilizing the information in a way that is fit for purpose. So this means focusing on asking more broad questions to evaluate trends and not trying to determine an exact design criteria to an exact point in the future. The Corps of Engineers also supports a series of research projects and pilot studies, as well as collaboration targeted at developing climate-informed science in support of water resources applications. We partner with the National Center for Atmospheric Research for a lot of our funded research projects, which include approaches to selecting outputs from Earth system models in support of water resources application, approaches to evaluating the reliability of downscaled climate model outputs, and refining hydrologic model fitness for climate change applications. We also have partnered with NCAR in support of performing project-based analysis, like the vulnerability assessment being done using climate-influenced hydrometeorology for the Columbia River Basin Treaty effort. We're also currently working in collaboration with the U.S. Bureau of Reclamation to update the available U.S. scale data set of CMIP-6 downscaled precipitation, temperature, and streamflow outputs. The CMIP-3 and 5 versions of these sorts of data are currently available on the Green Data Oasis website. That's listed on the slide, but right now we're working with the Bureau of Rec and NCAR to update this website with CMIP 6 based outputs. We also support a number of collaboration, including a couple specific to the region encompassing Minnesota. And those would be, for instance, the Climate Resilience and Adaptation Study for the Souris River Basin, currently being carried out using IJC and Cairo-based funds. And they're interested in developing and evaluating hydrometeorologic projections specific to that transboundary basin. We're also supporting the effort for Minnesota, building knowledge to support equitable climate resilience in the upper Mississippi River Basin that the University of Minnesota, NOAA, Cairo, and the Upper Mississippi River Basin Association is currently working on to modernize climate model-based outputs and streamflow for specific to the basin. So in summary, climate is changing and global warming will cause various impacts on projects that the Corps of Engineers is very concerned with varying levels of certainty and complex feedback mechanisms. And climate change is one of the many sources of risks and uncertainty to our projects. Our climate change assessments are focused on relevant climate factors, are used to inform plan formulation and decision-making, and our analyses are scaled to the decisions being made and project risk. The Army Corps of Engineers is dedicated to developing tools, guidance, and research to aid in the characterization of climate change impacts. And that finishes my presentation today.
Well, thank you, Chanel. That was wonderful. And it looks like we've got one question in the Q&A, so we can save it for later, or if you feel like typing an answer and then addressing it later, just let me know. Or feel free to go for it. But thank you so much. That was a really interesting perspective for me to hear, because I'm not from a hydrology background, so it's cool to think about all the different ways that you are considering uncertainty and changes for the future. I'm going to hand it over to Quetzal now. If you would like to try out sharing your screen, and we'll go from there. Oh, and Chanel, could you stop sharing your screen?
All right, let's see how this goes.
No problem.
How is that looking for everybody?
Perfect. Thank you.
Sweet. Should I go ahead and get started?
Yeah, take it away.
All right. I will. So, as was mentioned, my name is Quetzal. I work as a meteorologist at the National Weather Service office here in Duluth, Minnesota. I'm also on the hydrology team here. So we don't have a set hydrologist position, but we have a number of us who work together to talk about all of these hydrology things. Opposed to kind of the overview of tools and projects that Chanel had, I'm going to be looking at a little bit more of a case study. So this is a recent spring snowmelt flood instance that we had, how we responded to it, and the projects that we've taken on to kind of improve our climate resilience and improve our water resilience and our partnerships in that area. So This is post-record 2022 flooding up in the Rainy River Basin. As a quick intro, if folks are not familiar with the Rainy River Basin, which happens pretty often, this is kind of the north of the divide. So in northern Minnesota, we actually have two continental divides that come together. And so there's the Mississippi Divide, and then there is the St. Lawrence Divide, or I should say there's the Laurentian Divide and the St. Lawrence Divide. So we have three watersheds going into the Mississippi, into the Great Lakes, and then a northern watershed, which is going up into Hudson Bay. And that is where the Red River and the Rainy River are going. So they are actually all flowing north. And if we zoom into Minnesota itself, you can kind of see a zoomed in portion of where that Rainy River, Lake Superior, Upper Mississippi delineation is. Further zooming in to the watershed, just kind of taking a look at it, the far eastern reaches are the headwaters of the Rainy River Basin. This is largely comprised of areas like the Boundary Waters and the Quetico and a couple larger lakes. But if you were just sitting in that area, you wouldn't necessarily know that water is flowing anywhere. But it is. It's very slowly making its way to the west. So it eventually gets into the area of Voyageurs National Park with Kabetogama and Namakan Lakes, and then Rainy Lake, and then flows through the Rainy River, which makes up the international border for parts of northern Minnesota, and eventually into Lake of the Woods and beyond. So it'll eventually get to Lake Winnipeg, and then further off into Hudson Bay. And where are we coming from the National Weather Service as far as who services these places? So there are two main entities that I'll talk about. One of them is, of course, the Duluth office. So that is one of our local weather forecast offices. And then we also have river forecast centers, or RFCs. And this area is serviced by the North Central River Forecast Center. And we worked together in collaboration with a lot of the other partners to try and deliver forecast services and then follow up on what else we could do afterwards. So as with any good case study, the first little section of my presentation is actually just going to be me walking through what happened in 2022. And to do that, we actually have to take a step further back and talk about what happened in 2021. If you were in northern Minnesota in the summer of 2021, you'll remember that it was largely characterized by smoke and drought and wildfires. And so that was the kind of impression that we went into the winter of 21 to 22 with. But by the time we got to May of 2022, we had pretty much entirely gotten rid of all of that drought. So here's a look at the precipitation accumulation trace for international falls from April of 21 all the way through July of 22. And you can see that we were below that normal brown line for a really long time. And then we kind of started to creep up towards it and then absolutely exceeded it in the spring. So our precipitation deficits were largely erased with spring rains. And additionally, the winter pattern that we had in 2021 was one of a lot of Alberta clippers, which are these low pressure systems that kind of continuously come down from Canada and just sneak right past. And these just came over the international border over and over and over again, to the point where our October through May precipitation was 150 to 200% of normal precipitation. And it really targeted that Rainy River Basin area. On top of that, not only did we have quite a bit of precipitation, we also had a pretty cold winter that year. So these are the temperature anomalies is what you're looking at for February, March, and April. And you can see especially February was far below normal temperatures. And what this did is it made it so that frost made it far, far into the ground. So we had very frozen soil, and then we put a lot of precipitation on top of that. And a lot of this precipitation fell in the way of snow. And the way that we measure how much liquid snow has is through a measurement called snow water equivalent, or SWE. And this was a look at how much of that SWE we had across the area at the end of April. So we had a very cold spring. We had a lot of snow that stuck around well into April in the spring of 2022. And you can see that across the entire basin, we still had anywhere from 2 to even 6 to 8 inches of liquid contained within the snow. So that's not the snow depth itself, but the amount of water that is sitting in the snow, and we ended up losing it really quickly. So as we went into early May or late April into early May, we went through a pretty rapid warm up, and we also had rains fall, which led to pretty rapid snow melt. So this was 1 week later on May 1st. We really saw that snowpack just eating away, and we've lost, anywhere from 2 to 4 inches of liquid at this point. And then another week later, we had almost lost it. This is according to a model that is not the most refined. So there was still snow on the ground at this point, especially in patches, but it wasn't widespread liquid that was still being held in the snowpack. At this point, it had been melted out and was going through the watershed. So this is a look at the Big Fork River, which is on the western edge of the Rainy River Basin, how this looked on April 26th. And this was right as some of that melt was beginning. We were already seeing pretty rapid river rises and really strong stream flows going into portions of this basin. And notably, this river, you have to remember, we were coming from a place of drought. So this is what this river had looked like just the summer before. And so we were dealing with really low stream flows, a lot of scrapable conditions, a lot of just rock in some places. And this was a really quite the 180 that the area was going through. We had major rises on rivers. The DNR ended up sacrificing docks because of all of the debris that was getting caught up and floating downstream on rivers. And it started to impact homeowners and resorts and other private infrastructure. And we had this rain on top of snowpack and frozen ground. We had several instances of that led to a lot of the water not going into areas that would normally get water to go where it needs to go. So instead, we were washing out gravel roads, and the water was just taking the most direct path that it could. And so we had a lot of water going all over the landscape really, really quickly. A lot of my presentation is just a lot of images of what we saw, so hopefully folks appreciate those. But just generally, by the time we were into early May and we had had a lot of snowmelt and our first rain on snow event, water was on the rise across the entire area, and especially in the headwaters. It hadn't necessarily made it downstream yet, but it was rising across the entire area. And so water was rising slightly further downstream as well as in the headwaters. So that headwater rise didn't have a lot of places to go. It just kept going up. This is on Rainy Lake and in Voyageurs National Park. There were docks that were completely covered. There were campsites that were underwater. There were a lot of campsites that ended up getting closed through a good chunk of the summer. And a lot of docks, if they are not solid docks attached to the ground, they end up floating up with the water and breaking off. So they actually have to be weighed down in order to not have that happen. And these rises, when we look at some of the main bigger lakes in the Rainy Lake Basin, like Namakan and Rainy Lake, were only the beginnings. So that April-May timeframe, when we look at where these lakes ended up going, they still had at least several feet of rise to go. So the y-axis is not the clearest on these images, and I apologize for that, but you can see right here from where it is circled in the kind of magenta pink color to where it peaked is the difference of anywhere from 3 to 5 feet. So they had another 3 to 5 feet of rise left to go on these lakes. And you'll notice the dashed blue line, that is the rule curve for these lakes. So both of these lakes are dammed, and ideally they are kept within those blue dashed lines, and anything out of that is considered flood stage on the high end. We then made it into mid-May and we had another rain event. So this is just a look at the precipitation that fell with a mid-May rain event. We had just flash flooding that occurred from this, but then of course it was more water on top of ongoing flooding that was already occurring. So anywhere from a half to several inches of rain fell. And after that, we just saw everything become more exacerbated. So we continued to see washouts and sandbagging being needed to protect infrastructure and roads starting to close as well. And this just kept going through May. This image on the left, you'll notice this is a Forest Service ranger who is actually standing on top of a campfire grate. So this is a Boundary Waters campsite that they have just paddled right over, basically. And then on the right-hand side there, that is Mallard Island, which is a historical site on Rainy Lake. And they took great documentation of all of the flooding that happened there. You can see the stairs. There's at least 4 or 5 stairs that are supposed to go down to the water's edge. And this was also the point as we were getting into mid to late May when we started to talk about breaking potential records on these lakes. So the image on the left is a cabin or boathouse back in 1950, which is when the previous record had been set on Rainy Lake for high water. And then you can see the image from May 23rd of that same cabin, and you can kind of count logs and see that you're like, yeah, we're a couple logs away from seeing this water, and we were expecting that water would just continue to rise at this point. Later in May, we had even roads like state highways that started closing or having to receive emergency grades in order to keep traffic flowing in certain portions of the watershed. And then we got more rain on top of all really high water that was trying to get through. So we had Memorial Day weekend with more rain on the 30th and the 31st. And so we ended up being so far above normal for precipitation, flip-flopping from this drought. And so our May precipitation, April and May precipitation, both really, really far above normal. And this is, again, we're using international falls as a proxy because we have a really long period of record there for precipitation. And eventually those records did fall. So on June 3rd, Rainy Lake would rise above its all-time high and break the record that was previously set in 1950. And then it would continue to rise for another 2 weeks after that point. Finally, in late June, we got a little bit of a dry period in late June, and this water was finally able to start making its way out. And this was also partially because, not only because it was a little bit drier, but because the water further downstream was able to move somewhere, allowing the water in Rainy and Namakin Lake and further in the headwaters to start to move out as well. And so this is just a couple more examples. This is a Voyageurs National Park campsite on the left, and then this is again that Mallard Island site on the right, and you can see those high water lines on the door frame. So this is as water was just starting to come down, and this is June 26th that we're talking about at this point, and we've maybe dropped about a foot here. So finally, we were able to decrease back to normal, and we've seen these charts before already. And the one thing that I want to point out is just how long we were above those dashed blue lines, which is considered kind of that flood stage. The x-axis there is we rose above that point in April and did not come down until July or August. So it was several months worth of being in that really high water, and in some cases it was 5-6 feet above that normal level. So that's kind of the case study. Then looking at what we did on our end as far as trying to forecast what was going to happen, trying to coordinate across an international border, trying to just give folks as much information as we could provide. There are a lot of limitations and challenges that come to this area, and partially one of the biggest ones was limited gauging, so limited stream flow gauges just to know what was happening in the moment. And then also limited ground truth observations. We're working with a really rural area, and so we weren't entirely sure just how much snow water we had on the ground, for example. We also didn't know about ice effects. Is there damming going on? Are there backwater areas? We knew that ice on some of the bigger lakes would lead to some dock damage with high winds and waves, but what else was going on? So the modeling that we had previously was pretty limited. And there was a lot of coordination that had to happen in order to put any message out whatsoever. So there was coordination between us and the RFC, and then also with the Army Corps of Engineers. And then because we are straddling an international border, we had to also work with the International Joint Commission and the Lake of the Woods Control Board. So there was a huge group of us that were trying to figure out what was the forecast, what was the message we needed to send, what resources could we get people, and that coordination ended up being key. So what we ultimately ended up doing was we coordinated a forecast 3 times a week. It was a 7-day forecast, and we put that message out Mondays, Wednesdays, and Fridays. That forecast information went out, and we had a live briefing of once a week. And we did a bunch of other things as well. So we really spun up in what kind of messaging could we provide. So we developed an entire web page that was hosted at our office. We had that 3 times a week slide deck, webinars. We were obviously issuing our warnings and outlooks like we would normally have. So there was an aerial flood warning in effect for a couple months. And we talked with the media. We had in-house talking points, so all of our meteorologists knew what was going on. And I'm not going to read through all of these, but just kind of a look at a timeline of services that we provided. This was the first half and the second half. And this is a snapshot from one of my coworkers' emails about Rainy River Basin flooding is what he searched for, and just how many updates there were in just that short amount of time frame. So in this first initial part, communication and that decision support to our partners was very successful. We had to spin up really, really fast for this area to try and provide as much information as we could, because we didn't necessarily have a spring outlook for it, since we weren't explicitly forecasting points there. But it was a struggle to get all the observations that we needed. Half of this area is across the international border in Canada. How do we understand what's going on there? What kind of collaboration can we do? And any kind of in situ observations, so on the ground observations, were pretty limited. And so we took all of this and we said, all right, we can do way better in providing service, and making these partnerships so that we're prepared for the next time that this happens. And so as we look to the future, we had three main points. We wanted to expand our river forecasting points within the Rainy River Basin on the US side, because that's what we can control. We wanted to solicit more observations through both our partners and then a program called COCORAS, which I'll talk about in just a slide. And we wanted to keep that webpage going with seasonal updates so that the people who relied on that information could always find it and we could always have something available for them. And so that was fall of 2022. We kind of made these goals and worked towards them and said, well, it might be a little bit. This is the federal government. We don't always move the fastest. But by the time we got to September, October of 2023, we actually accomplished every single one of these, which was really, really exciting to see. So one of the things that we did is we used a program called COCORAS, which is the Community Collaborative Rain, Hail, and Snow Network. I'm actually the local coordinator for that program in our area. And we said, we need more observations. We especially need more winter observations in this area. And so we worked through our channels, through our partners' channels, to put out this huge recruitment effort to try and get more observers. And it worked. We got not a lot, but we did get some new observers, and they were really dedicated. And they took more SWE observations and rain observations and put notes about what was happening in their area. And so we started to get more observations. And the really great thing about COCORAS is they're using standard calibrated equipment and getting training. So these are high quality observations, and the network can be as dense as many people sign up. We also brought in 3 new forecast points. So this is a place where if flooding is expected, a forecast is issued. So we gathered impacts and set flood stages. This makes coordination with international partners more easier too, because this is a standard service that we provide. And then we also created a really robust contact list for any weather and water briefings. So we now have a whole contact list for our Rainy River Basin partners and stakeholders so that we can reach those people really easily with information. And we had great success. We also, in conducting snow surveys. So in addition to going through and using the COCORAS network, we also did our own snow surveys where there were some spots where it was like, nobody lives here, but I can get right to the edge of the wilderness and take my own snow measurement. And that Old SWE measurement, we were able to really build out that observational data set. So here's a look at the new forecast points. They worked really, really well last spring. A lot of areas had some pretty severe spring snowmelt, but this basin did not, which was really great. So we released these 3 last spring, early last May. And we've got, we're working on getting at least a couple more, hopefully kind of calibrated, but they needed more calibration and more time to get those ready to go. But we had at least 3 that kind of spread out across the Rainy River Basin to give some information. And we had really great feedback from community stakeholders. So last spring, we had a lot of snow on the ground. We had record-breaking amounts of snow on the ground that came with record-breaking amounts of snow water as well. And we had a lot of flood warnings go out across other basins in Lake Superior and in the upper Mississippi basins as well. But our forecasts and our modeling showed we're going to get really close to flood stage in the Rainy River Basin, but we're not going to quite get there. And we had increased confidence in those forecasts because we actually knew how much snow was on the ground. And so this is feedback from one of the community stakeholders that said, they were also proven correct in their call for no flood warning in our area being the Rainy River Basin, which is not a small accomplishment. They had the right data to make the correct call and did the right guidance needed for stakeholders in the region. So that was really great to hear. And then this is a comparison of observations between 2022 to 2023. So I just picked a week at the end of February, basically. And this is on the left. These are just the SWE observations, so snow water equivalent. And the dashed white line is roughly where the Laurentian Divide is. So north of that is the Rainy River Basin. And you can see there's a pretty clear, obvious difference between these two images. And that is huge. When it comes to modeling, we have to know what's actually happening on the ground before we can say, this is how much stream flow you're going to get. You can't model stream flow very well without knowing how much water is actually in the basin. And so this was a combination of increased recruitment of observations, and then some of these are also the snow surveys that we did across the area. So what happened? This says this year. These are some slides that I presented last October, but what happened in 2023? You can see the comparison to 2022. Like I said, 2023 had near record amounts of snow on the ground across the Rainy Basin. It went from anywhere near highest snowfall to at least top 10 snowfalls ever recorded across the Rainy River Basin. And there was increased coordination. There was a further drawdown. You can see that dark blue line was drawn further down to the bottom of the dashed blue. And we just barely popped over the rule curve, just the slightest amount, about maybe a quarter to a half a foot above the rule curve, and then it came back down. So there was increased coordination for, what the dam operators were going to do, how they were going to draw down to account for that water, and also just increased confidence in knowing what was going on out there. So that was Rainy Lake. This is Namakan Lake. Namakan Lake ended up kind of popping up just a little bit more, but again, it was about a half a foot to a foot, and it was for a much, much shorter time before that came back down and stayed within its rule curves for the rest of the summer. So that's just a look at what we're doing. We're a little bit more focused on the weather side of things than we are the super, super long-term climate things. But at the end of the day, creating these forecast services and these connections with our partners and community stakeholders and furthering our observation network is all going to serve us to a huge extent as we continue to see these extreme flooding events. My information is on this slide, as well as many other folks who contributed to all of the services that we provided, as well as this presentation that we've been able to present a couple times. So if you have any further questions, you're welcome to contact myself. If you have any further questions about the CoCoRaHS program as well, you're also able to contact me, and I can get you to where you need to go. Thank you.
Well, thank you very much. That was wonderful. And it was really interesting to see, like Chanel has showed all these different tools and how you can look at that, and then seeing some of that on the ground as a case study. Those pictures were really impressive.
Yeah, I have more too. I have a slide deck of about 200 slides that was just us collecting impacts and photos of what was going on so that we could actually know what happened on the ground, so we could, calibrate our models to that.
Yeah. Wow. Well, thank you. And I'm gonna pull up just some discussion questions for all of us to go through, and then folks in the audience, please feel welcome to use that Q&A and start putting some of your questions in. I saw Chanel answered a really great question earlier about how communities can get involved. So CoCoRaHS seems like one great way, but Chanel also put some links and some answers in there as well. So check that out. So these are just a handful of questions to guide us through discussion, and both Chanel and Ketzel, let me know. Yeah, you're both welcome to grab one or not. Sorry, I'm like moving this all over the place. My Zoom disappeared. There we go. So one question that I kind of wanted to kick off with are, from your perspectives in hydrology and meteorology, what are some key areas or strategies for adapting to changing climate? Maybe like thinking short term, so some of the what Ketzel talked about, forecasts for the short term, or long term, some of those tools that Chanel talked about. So whoever wants to grab on, feel welcome.
I can kind of take a stab at it to begin with, but for me, like I mentioned, we are a little bit more focused on the short term, we're focused on the weather. We do a 7-day forecast and we try to do outlooks beyond that. But I have found in my experience that one of the most important key area strategies is actually just making that connection with communities and stakeholders that are going to be the folks that are some of the most affected by these changes that we see with extreme events, so that we know we have that connection with them. They trust us in our services. And also we have a two-way communication of what's going on, and we can teach folks, where do you find that latest forecast? What kind of resources can we provide you? And what kind of feedback do you have that we could maybe do better? Ends up being a really powerful tool from our area, is just having that connection with community members, and having that trust and respect that goes both ways. So that's pretty powerful. But also on the science side, we're trying to create more forecast points. We're trying to better understand what kind of impacts we've had historically, and with every event that we do have that happens through the future. We had a really rainy September last year, and it was really crucial that we got out and immediately documented those impacts. And those are now turning into the potential where, now that we know what actually happens and we can combine that with some historical impacts as well, we can better calibrate our models to do better next time. And we have to continuously feed it that information so that we can be better adjusted and calibrated for those extreme events.
Oh, awesome. Chanel, I saw you unmuted.
Yeah. I totally agree. I think maintaining our ability to better understand current conditions and also understand what's kind of transpired historically in the observational record is super important. I think that is how we can build out some of our adaptive management approaches to mitigating for climate change risk in the long term, by monitoring and evaluating where we see those risks materializing. In the short term, it's sometimes hard to justify adding resilient features to projects from a federal perspective because of the uncertainty associated with climate changed hydrometeorology. So that's why I think that adaptive management approach, which enables us to account for that uncertainty effectively by developing monitoring plans and making the way for us to be able to adapt our projects in the future as either climate modeling output matures, or we can start to see the observational evidence in the observational record, and then we can take that sort of action in the long term. I think it's also important to appreciate that when you look at the climate model based output, a lot of the signal resulting from climate change and precipitation and stream flow that we might see only begins to really materialize out of the kind of normal climate variability over the next 50 years or so. So it's that kind of longer term horizon that we're going to see the effects of climate change start to become more impactful in terms of floodplain management and such. So that's why I think that being sure that we make our modeling and monitoring networks robust so that we can kind of take that sort of adaptive management strategy and kind of evaluate where along the trajectory we are and when we need to start taking action.
Well, great answer, both of you. Thank you. It's really cool to have, like, yeah, we've got two kind of slightly different time horizon perspectives here. So I think your answers fit really well together in thinking about all of that. The next question I have on here, oh goodness, is what are some of your main concerns? So are there concerns that you really have in mind, like gaps or needs that we have, or thinking about communities, that sort of thing? What are some of your main concerns looking into the future?
I can go first on this one. I think my major challenge is kind of taking the outputs from climate change models and what we're seeing out of that kind of information and being able to use it in a way to effectively justify projects. Right now, the Corps of Engineers generally relies on like a cost benefit sort of framework. And as a result of applying that framework, the effects of climate change are so long-term that it's hard to economically justify features at present because of both the long-term nature of climate change And then also because of the uncertainty, so when the uncertainty bands increased a lot, it kind of takes away from the power of the information being able to translate into that cost benefits ratio. So it's like, what kind of creative solutions can we come up with in order to more narratively justify resilience into projects now versus waiting a long time into the future? Because sometimes you need to take action now in order to even enable our projects to be adaptable in the future, or it would just be more cost effective to do it now. So these are, I think, the biggest concern I have.
Thank you. Ketzel, did you have any?
Yeah, it's a little bit of a hard question for me, just because it's like some of my main concerns are just like weather-wise, when is the next extreme rain event going to hit? Or, when is the next record snowfall going to come? Because these are trends that we're seeing with climate change, is that we have these more extreme weather events that are happening. And are we prepared for that in our infrastructure, for example, which is not something that we can control at the Weather Service, but it is something that we can understand. And so, like, having that base knowledge of understanding about where do we have infrastructure that may not have been rebuilt to a new level of flooding or precipitation, where do we have some of our most vulnerable communities, and how can we better serve them? So we think a lot about the vulnerable communities that we have in our area, whether that is folks who are in the wilderness, whether that's tribal communities, whether that's folks that are living in places that have not seen those culverts replaced yet, things like that. And how can we better get the message out to them? So yeah, my main concern is, when is that next flash flood emergency going to happen, or the next record amounts of spring snowmelt flooding? And can I be better prepared for it next time?
Yeah. Wow. Great answers, both of you. Chanel, did you have something to add to that too?
No, I'm good.
Okay, no problem. But that leads really well into this next question. So thinking about envisioning the future, how can adaptation efforts in your field or beyond more fully embrace equity? And so Ketzel touched on this a little bit, talking about vulnerable communities, for example. So how do we prepare in ways that address community needs and those particularly vulnerable communities, so that we're advancing equity? We're, even though climate change is scary and it's hard and it's a lot of change, how can we make sure we're moving forward in a way that brings everyone forward together?
I guess I can speak to that in terms of, like, the Army Corps of Engineers and the federal government is very focused on meeting the needs of underserved and overburdened communities, because oftentimes these are the communities that are most impacted by climate change, and may lack the adequate resources to address these multiplying changes. So we want to provide opportunities for environmental justice communities and tribal nations to participate in climate adaptation decisions actively that impact their communities, and make sure that we engage in knowledge sharing and communication with regard to climate change impacts and resilience planning, specifically with these critical partners. So that is really central to our goals as an agency and as part of our climate preparedness and resilience community of practice.
Awesome. Okay, so did you have?
Yeah, there isn't the really big high level stuff is not something that we're necessarily involved in, but some things that we work on, I'm going to sound like such a broken record with just like the making community connections, things with our local community, but we try to do as much just kind of informational pushing out information and resources and knowledge. And we try to contact some of our critical partners are those who are the leaders or emergency managers of our more vulnerable populations. So most tribes in our area, at least, have tribal emergency managers, and we make sure that they are always on our lists. We're always in contact with folks at National Park Services and Forest Services and things like that. And so just kind of constantly pushing our message of, these are the weather hazards that we have. This is, what we're looking at, trying to get as much information out there and figuring out what they need to make their decisions too. So one of the critical things that we do is just called what we call decision support services, which is giving them all of the information they need to make those decisions. And it again is much more focused on the short term, just because of the nature of what we do, but just trying to be there to give them that information. And on the flip side of that, as far as just trying to reach out to the general public and community stakeholders as well, an example of that might be something like the Skywarn classes we teach. So each spring, many National Weather Services offices go around and teach these Skywarn classes, which focus on severe weather and how can you better prepare for severe weather. What do you do to stay safe when a severe thunderstorm warning is issued, for example? And how can you report back to the National Weather Service to help us as well? So that kind of thing, there's a real just kind of baseline knowledge that getting everyone to that baseline is really powerful.
Wow, awesome. I've taken those classes too. So I learned how to identify funnel clouds and what's not actually a funnel cloud, that sort of thing. So those are really cool. Thank you, both of you. So the last question that I have, and then again, we'll go into the Q&A from the audience, is what is the future you would like to see, even in the face of changing climate? So what are some of your hopes for the future? So whether that be hydrologically speaking, what kind of infrastructure, or community speaking, really broadly, what are some things that you think about when it comes to your field or yourself for the future?
I think for me, there's a huge range of this, but we can kind of sum it up with just being weather ready, storm ready, for folks to have that kind of baseline knowledge of, what do I do? How can I help? Being prepared themselves for storms. I can't do a lot to help you as far as the huge climate change question goes, but I can say, this is what you can do when a flash flood warning is issued, and this is how you can know ahead of time about that weather that's coming. And if you are interested in helping fill in the observational data gaps, here's what you can do. And if you're interested in being a citizen scientist, or if you want your kids to understand science better, here are some resources I can give you to make sure that you have that kind of generational knowledge that's coming as well. So that's my hopes for the future, is just that continued knowledge building for our entire community, in the hopes that we continue to see these connections being fostered and growing to a point where we're all kind of on the same page, and we're really kind of this weather ready nation in a way that we can take on whatever those extremes happen to be.
Oh, nice. Chanel, did you have any thoughts?
Yeah, I suppose I would really like to see us have that concurrent focus on mitigation of carbon emissions, along with being dedicated to more adaptability to future change. So in terms of mitigation, I know the agency is really focused on encouraging initiatives targeted at reducing energy, using low carbon materials in construction and stuff like that, where it makes sense. And then on the adaptation front, I really want to be able, I'm really a strong proponent of wanting to see us bring the climate model based information into a space where it can be more readily used in support of decision making and justifying climate resilient project features and adaptive management approaches. So that's kind of what I want to see as we move forward.
Awesome. Well, at the MCAP, the climate adaptation, we love to hear. So thank you both for those great answers. So now it's just an opportunity for the audience to ask questions. So I have, it looks like we have one question already in here from Nancy, in addition to the one that Chanel helped answer earlier. So where is the funding for these excellent programs coming from? One short and long-term risk would be loss of funding depending on who is governing. So that's a very timely question. Do either of you have any thoughts?
To be honest, we don't work in the funding world very much in the Weather Service. We certainly write letters of recommendation when things come across, and we certainly see the impacts of things not being funded anymore. So I certainly can empathize with that concern. One thing that we see, for example, is not kind of in the hydrology world, but on the big water side of things, is what kind of buoy observations we have on Lake Superior. Many of those end up being funded through research groups at universities or through more larger research organizations. And it tends to be really interesting to get the initial funding for that, but then the funding to continue to put that buoy out year after year sometimes ends up being a little bit more difficult just of applying for it again. It's not a new fancy project anymore. It's just a continuing data source, which is really important to our operations and to marine users, but continuing to get that going. So we see a lot of luck with many of our stream gauges being through USGS, DNR, that have that continued goal of that scientific information. So I think that's really powerful, is leveraging those kind of agencies. But we don't do any of the funding on our side, so I'm just kind of empathizing with Nancy's concerns.
Yeah, it's a bit of a hard question for me to answer as well, because it's definitely not an area I get involved with directly as much. Our Army Corps of Engineer responses to climate change program has a specific budget, and I would say that yes, that is probably sensitive to like the administration and how much money we get budgeted for. The Corps of Engineers have a lot of programs from which we draw funding. Like examples would be like our Silver Jackets program or floodplain management services program, planning assistance to states. All our projects are project funded. So, and that kind of stuff I think would be less sensitive, and they would still be required to apply our climate change guidance and policy, but perhaps our actual responses to climate change program budget might be a little bit more sensitive.
Well, yeah. Well, thank you both. I was really the buoy example is really, that's a good one to me, thinking about that as well. I don't think we have any other questions in the Q&A yet. If any of my teammates have questions, let me know. And we still have a little bit of time yet before we wrap up. I've got a few slides to wrap up as well. So yeah, think about those urgent questions and I might kind of move us towards closing. But I just want to say thank you so much again to both of you. I think I've learned a lot personally from hearing both of you. So yeah, I just really appreciate having you both here to think about some of these questions together and all of the tools and resources you shared and all the work you're doing. So we have a survey if people would like to fill that out about your experience today. So we do really take that seriously, and we're trying to make these webinars as helpful as possible for our audiences. So yeah, please take some time to fill that out. And yeah, let us know what you'd like to see for future webinars as well. So as I mentioned, we have one coming up in August this summer, and then we'll have another one in the fall. And then if you're curious about more climate news, you can use the QR code on the screen or follow that Z link at the bottom, z.umn.edu/MCAP updates. We've got a brand new shiny website, so go check it out. And I also encourage you to connect with Chanel and Quetzal as well. They shared so many really good resources. So yeah, please utilize those. And then the last thing I'd like to do is remind you all again of a very upcoming opportunity for you to learn more about some using climate projections. So this is the Minnesota Climate Mapping and Analysis tool, and we'll have 3 different sessions like I mentioned before. So you can learn to use the tool and learn some of the basics of climate data as well. And this is very high resolution data. You can zoom into kind of a neighborhood or county level. I've got the Z link down there, z.umn.edu/May 23rd, 3rd, and MinClimate/webinar. The other dates are just replace the date and check that out. But me and my partner, coworker, Susie Clark, will be working on that this weekend to go forward. So other than that, if folks don't have any pressing questions, we can all give you 15 minutes back. And again, this recording will be available to you on the YouTube page. So if there's something you wanted to replay, learn more about, check that out again. But yeah, I think now's your chance, but I think we're good wrapping up just a little bit early. And I thank you both again.
Yeah, absolutely. This was great.
Yeah, thank you so much.
Thank you for having me.
Yeah, and keep in touch. We'll send out the recording to both of you as well. So if you have folks you want to share that with as well, yeah, we'd love that. But yeah.